So this example introduces us to solving linear equations in two variables. When we have an equation in two variables, usually that equation represents a formula of some sorts. And when we solve for a variable, we do not determine a specific number value because we have another variable involved. We're just representing the formula in terms of the other variable. And this is important when we want to express or emphasize one variable from another. So this example says, the formula for changing temperature from degrees Celsius to degrees Fahrenheit is C is equal to 5/9 times F minus 32. And this is a linear equation, but it's in two variables. C represents Celsius, and F represents Fahrenheit. We want to write the formula in terms of F. Right now it's written in terms of C. C is 5/9 F minus 32. We want to write it in terms of F. So F is going to be equal to something. And of course, we're going to use the same manipulation and the same algebraic properties that we use when we were solving to come up with a numerical value, except we're going to be rewriting it in terms of the other variables. So we'll just go ahead and I'm going to put down C is equal to 5/9 F minus 32. So the first thing I would like to do is I'd like to get this 5/9 out of there because I want to isolate the F here. So in order to get rid of this, what we've done in the past is I could either go ahead and multiply both sides by the reciprocal or multiply the whole thing by the reciprocal. I like to do it that way. It's just a little clearer for me. But you can do both sides, but I like to do it this way. So the reciprocal of 5/9 is 9/5. 9/5 times 5/9, 9 times 5 is 40, 5 times 9 is 40, and 40/40ths is the same as 1, and we don't have to express 1. We can just go ahead and cancel it. So the 9/5 will wind up canceling this here. So 9/5 times C, that's 9/5 C. Don't forget, we multiply this to every term in here. Now imagine we have C is equal to 5/9 X. And I wanted to isolate the X. So in other words, I have to get rid of this 5/9. So I would go ahead and I'd multiply either side or the whole thing. I just like doing the whole thing by the reciprocal, 9/5. And that's exactly what we've done here. 9/5 times C, that's 9/5 C. And then 9/5 times 5/9, well, that winds up canceling. And I'm left with X. Over here, it's the same idea, except I don't have X. I have F minus 32. But the same idea applies. The 9/5 times the 5/9, they wind up canceling. So now I have this equal to F minus 32. Then I could use an addition property. I can add 32 here. I'm looking to isolate F. I'm going to add 32 here. Of course, negative 32 plus 32, they wind up canceling. And I'm left with 9/5 C plus 32. That's equal to F. So here, the linear equation is expressed in terms of C. C is equal to 5/9 times F minus 32. And here, it's expressed in terms of F. It's the same linear equation, except it's being expressed with one variable as opposed to another. But F is equal to 9/5 C plus 32. And there we go.